Today we're going to talk about how to predict synthesis reactions. Let's first look at what is a synthesis reaction. A synthesis reaction is when A plus B come together to make AB. Or in other words, an element plus an element makes a compound. So the two elements just combine to simply make one compound. So this is a fairly easy reaction to predict the products for. So let's take hydrogen gas plus oxygen gas. Okay, you're not going to be told this is synthesis. The first thing you have to realize is we only have two elements here, pure hydrogen and pure oxygen. Now, when we go to write the products, we want to put the two elements together. We do not want to bring the subscripts with this. Now, you may be able to guess what this is going to make, but what we really need to do is check charges. Hydrogen has a +1 because it's in group 1. Oxygen has a -2 because it's in group 16. And we're going to switch them. So we get H2O. So hydrogen gas plus oxygen gas make water. Now the last thing, of course, we have to do is balance the equation still. We must always balance the equation. On this side I have two oxygens, where over here I only have one oxygen, so I need to put a 2 in front. Now that makes 4 hydrogens, so I need to multiply the H2 by 2 to make 4 hydrogens. Now it's balanced. That's how easy synthesis is. Let's try another one. Let's take sodium metal plus bromine liquid, and we mix them together. You got to remember which ones are diatomic. Bromine's one of the 7 that are diatomic, so Br2. So sodium and bromine come together. Then we check charges. Sodium's a +1 and bromine's a -1. So that cancels. So there is no need for any subscripts. Last thing, balance. 2 bromines on the left, so I need 2 bromines on this side. Now that gives me 2 sodiums, so I have to put a 2 in front of sodium. Try a few more practices. Let's take zinc plus fluorine gas. Now zinc and fluorine coming together, don't bring any of the subscripts. We're going to check charges. Zinc we know is a +2. We had to memorize that in the earlier unit. And fluorine is in group 17 is -1. So we're going to switch and it becomes ZnF2, which usually if you have a gas going over a solid, you're going to have a solid produced. The gas will just react with the surface of the solid. So now we're going to rewrite all of this. And the last thing we need to do is balance it. Well, we have 1 zinc on each side, 2 fluorines on each side, so it's already balanced. One very common reaction is sodium plus chlorine, which makes a very common compound that you use every day when you're eating lunch. We have NaCl, which is a +1 and -1, so that is balanced. So yes, this is how you make table salt. You take sodium, which is very reactive and burns in the air, chlorine gas, which is actually toxic, put it together, totally new properties, and we get sodium chloride or table salt. On the left, we have 2 chlorines, so I need 2 chlorines on the right, which gives me 2 sodiums on the right, so I need 2 sodiums on the left. All right, one last one. Let's go with oxygen gas and magnesium solid. This is a lab that we did. We burnt magnesium in the air and it combined and we got magnesium oxide. Now remember, when you're writing on the right hand side, to always put the metal first. So this first one right here must be the metal. Okay, then we're going to check charges. Magnesium's a +2, oxygen's a -2, so those cancel. And this is a solid, of course, just like it was in the lab that we did. Now to balance, on the oxygen side, we have 2 oxygens over here, so I need to put a 2 in front of this, which gives me 2 magnesiums on the right hand side, the product side. So on the reactant side, I need 2 magnesiums. So as you can see, predicting synthesis reactions is very easy. You bring the 2 elements together, do not bring the subscripts with you, check charges, and then balance.